Now, welcome to our class today. And I just want to take you through briefly on the SPSS interface. And I think you will enjoy the class. So let me just begin off the class. Now, I think you are able to. You can hear me. Can you be able to hear me?
Yes.
Okay. Now, SPSS stands for Statistical Package for Social Sciences. SPSS comes into the picture after data has already been collected. Data can be collected using what we call the questionnaires. Once the questionnaires have been collected from the field, then at least the questionnaires must be transferred to the SPSS. Questionnaires can be collected, like right now we are employing a lot in technology. We are using ODK, we are using what we call Google Forms. We have different technology means by which you can be able to collect data. So once data has been collected with those means, data must be imported to what we call the questionnaire. So I will be taking you through some basic steps that we normally do, especially with the first of all is coding how the SPSS interface. So what you are seeing in front of me here is SPSS interface. SPSS is designed like Excel. It is designed like an Excel, and it has two interfaces. The first interface is what we call as variable view, and also we have what we call data view. So the variable view is where we record the variable, just the way the questions are in the questionnaire. You need to transfer them to the variable view. And then the questions are supposed to, once the data has been collected, it's supposed to be transferred to what you call the data view, ready for what you call analysis. So I want to just take you through what you call the data view so that you can be able now to understand some of the basic principles that guide the process of collecting what we call data, okay? So this is very important. And then now in the data view, in the variable view, we have what we call how we now want to transfer how data is supposed to be transferred to this software. So the first part here is called naming of variable. Variable has specific way by which naming must be done. First of all, the name must be less than 64 characters. For instance, the name Peter is having 5 characters, 1, 2, 3, 4, 5. The name Peter is 5 characters, which means that name can fit, but it should not have what you call 64, less than 64 characters. Number 2, the name that we are going to put here must not start with what you call a number. It must start with an alphabet. So if you start with a number like 1, then you write Peter, then definitely SPSS will reject. It will tell you that there is an error. Variable name contains an illegal first character. So it simply means you have disobeyed the naming protocol. So another standard for naming is that the name must also not start with common notations like the common notations or abbreviations that we normally use. And then when we are naming, I normally prefer, especially for the people doing their project, you'll realize that the first questions may be demographic information. You can adopt what we call abbreviation system in naming. For instance, if at all you have 6 demographic information in your questionnaire, then why can't you name them like D? You use the word D, the first word D to represent demographic. So D01 simply indicating that is the first demographic question in your survey, 01. So that simply means that is the first demographic information in your survey. Then next one is D02. D02 is the second demographic information in your survey. Then D03 is the third demographic information in your survey. Then D04 is the fourth demographic information in your survey. Then D05. So this is the fifth demographic information in your survey, which simply means I'm using this abbreviation, and I know I understand this abbreviation well on my side because this is the first demographic information in my survey. Then perhaps you are dealing with what you call population survey, and then the first question is with the first variable is with regard to what you call population. So I will say population P01, P02, even 10 questions in the first variable. Then you go to the second variable that perhaps is called socioeconomic. So SC. So I will be naming it as SC, SC1, SC2, SC3 up to SC10. But if I have the SC variable as 10 questions, especially when we are designing our question in Likert scale. So this naming, you can use abbreviation, but it should be abbreviation that you can easily understand to aid your data analysis process. So this one I will just simply say P02, P03, P04. So in that order, I will be naming, I'm putting my variable, the main variable in what you call in abbreviation format. Then here, the next column here is called, type, the variable type. So here is where you need to specifically tell the SPSS which type of variable is it. Okay, so when you click the end here, you'll find the variable types are in 8. They are almost 9. So we have the what you call numeric. SPSS was designed to be taking care of what you call all numbers. So the default function here is numeric, which means it's a number that is being coded here. But you'll find that there are some variables that are not necessarily a number. Then you need to tell us which one is it. It can be comma, it can be date, it can be dollar, it can be string. So the most common one used here is either string or what you call numeric or a date that is being presented. Now, for instance, if at all the first question is write your name. Write your name. That is the question that you ask the respondent to write. Now, if you want to write a name, name is not numeric. So you come here and tell SPSS that it is a string. So that variable is a string. Okay, and then you label it here. Under label, you can extend this one and then write here write your name, indicate your name, indicate your name, your name. Now this is the section where you describe the variable fully the way it is in the questionnaire or in your ODK. What is it? So anyone that does not understand what D01 means, he will come and read it here, indicate your name. Then the second question or the second demographic information is indicate your email number. Indicate your email. Indicate your email. Your email. So now the respondents are supposed to write their email, contact address, or even telephone number. Even if at all you are interested in telephone number, you will be indicating there. Indicate your email or stroke telephone number. So that is what you expect the respondent to do, what to write. So even this indicating email variable is a string. So we come here and indicate it is a string because it is not a what? It is not a numeric. Then there's the third question is indicate your gender. Indicate your gender. Your gender. So now gender in this case, we shall just say gender is in male and female. Just put that gender is male and female. So if at all gender is a categorical variable, then we come here to values. And then values you come and now code. So you say 1 represent male. So 1 represent male. 1 represent male, you come here and write male, then you add, then 2 represent female. 2 represent female, 2 represent female. Then now you say okay. Then you say okay. So that's classic. That's what you now need to indicate under values. Here is where coding is supposed to be done. And we're only doing coding for what you call categorical variables. So the variables like which are in numeric or numbers, continuous or discrete, you don't need to put their values there because we don't code them. We don't give them what you call code equivalent to assist support our data analysis. Then if at all we have missing values, we shall put what you call the various codes for missing values. We normally use 99 and 98, not applicable and completely missing that the respondent has not answered. Then at least now we come back here lastly to what you call measurement, which is also very important here, that every variable must be, we must indicate how we are going to measure. For instance, how is the measurement of gender? Gender is a nominal variable. So we come here and indicate it's nominal. But then even the so-called string, like indicate your name, even name is a nominal variable, even in email is a nominal variable because there are identifiers. They are used to identify this respondent. So we said all identifiers are classified as nominal variable. When you want to use even serial number is a nominal variable because it is not supposed to be used for analysis. So it is just used for identifying that particular patient. A patient number in hospital, that is a nominal variable. Okay, then here the next question demographic is indicate your highest level of education. Indicate your highest level of education. That is the question. Indicate your highest level of education. Now the highest level of education is, suppose now we need to give codes because now education levels will differ. So we'll say one is somebody who has what we call the primary education level. This is the lowest level of education that can be accounted for, especially in this our country. Then number two is higher secondary school level. So secondary school level, this is the second level. Secondary school level is the second school level. Then number three is now those with the diploma. Those with the diploma certificates, those we say three is diploma. You come and here and write here diploma. And then 4 is undergraduate. So 4 is undergraduate. Give it a code of this is undergraduate. So a respondent perhaps who has reached what you call undergraduate. Then we say okay. Then 5 is masters. Master's level is master's level. And then 6 is what you call PhD. 6 is what you call PhD. So we say now we have already given what you call code. And if you look at the variable education, education simply is an ordinal measurement because it is ranked. We have simply ranked the various education levels of respondents from the lowest to the highest. So we already said that all ranked responses are classified as ordinal measurement. And therefore I come and say, okay, and then I come and indicate measurement of what you call education, and measurement there is ordinal. Then I come to the next question in what you call demographic information of my respondent, and I write about type of religion. Indicate your type of religion. Now we are measuring religion is one of the variables in this our study. So I will be able to do coding for what you call religion. Number one, I can give it like Christianity. Christianity is what you call number one. And remember, these numbers that I'm giving for nominal variable do not represent that one is greater or the other. So numbers is only used here as an identifier. So number two is now the Muslims. Number two here is now the Muslims, Muslims as a religion. And then number three is Hindus, Hindu religion, Hindu as a religion. And then number four is Sikhism. And then this number, I may say this is atheist. Those who do not believe in any religion, atheist. So I've given them number four. Now, when I'm doing that analysis, such kind of variables like one, I will only be interested in how many respondents are Christian, which means I need to run frequency. How many respondents were Muslims? This means I need to run what you call frequency. Hindus, how many were they and how many were theists? So such kind of variables, like when they are nominal variables, is best described using what you call frequency. There's no need for us to talk about standard deviation and mean for variables that are nominal in order. It doesn't make what you call any statistical sense for you to adapt that, which simply means when the variable is nominal, the best way to describe it is use of frequency. Then I come and say, okay. Then I come and indicate the measurement type, which is what you call nominal. Then now question number P01 is simply testing on population variable. Now this kind of variable, I will be indicating perhaps question now based on my survey questions that I placed in my question. And this is my first variable. So perhaps this question is in Likert scale. So when it is Likert scale, remember that are all ranked and there will be all ordinal. The measurement type will be ordinal. And the first scale I will put there under values, I will be able now to put each and every values. And I called all this is where I transfer the way my questionnaire is. I need to transfer them under what we call the variable view. So this is just a very simple process that each and every one of us can be able now to do what you call as a test example. Just take one of the survey questions that you have and transfer them into what you call the variable view. It's very easy. You only need to obey what you call under naming is where there's what you call naming protocol that must be observed. Number one is that the starting of the name must be alphabet. And also there should not be any space or any comma that is used inside it. Like for instance, I all spacing. For instance, when I'm writing the name Peter Nyachome, when I put a space in between and then the spaces will refuse. That variable name contains an illegal character, which means I'll put a space. So when we are naming, it must only be one. There should be nothing like the space in between that and naming. It must only be one. Even if the letter is so big like what, just ensure that it is one. There is no space in between your naming. These are some of the rules that are observed when you are doing what you call naming. Once you observe all those rules, or you adopt even this abbreviation system, like most of those people who are in monitoring and evaluation, you will find that when you go for what you call practical interview, they will find a very big data set, but the naming system, they adopt what you call the abbreviation system just to identify the variable. But if you want to know which variable was it, you come to what you call label, data label here, where you now, there is going to be what you call full description of the variable itself. Good, that's just an illustration that I wanted to do. These are very simple exercises that we are doing now, right now. Now, for instance, right now, that I've already collected some of my survey questions. So, for instance, I've collected response number one has already given me the survey answers. So what has he had already given me? So the first question was indicate your name. So I'm going to be the first respondent. So indicate my name. So when it is indicating my name, I'm the one that I want. My name is Peter. My name is Peter Nyachome. My name is Peter Nyachome. Now you are finding that when I write Peter Nyachome, it can only accommodate how many characters? 1, 2, 3, 4, 5, 6, 7. So it only accommodates what you call 8 characters. Others cannot be fitted here. So you go back to your variable view and extend the space. So the first question the length needs to be increased. So it must be more to accommodate all, like even also the email, telephone number. Telephone number will be more than 8 characters. So I need to extend. Also, so those are the ones that I need to extend. Indicate your name, indicate your email or telephone number. So, but because of that, now I can go back and I insert the name Peter Nyachome and it will just come very, very well. So now look at Peter Nyachome, Peter Nyachome. So it can now fit very, very well there. So you will be able to see my name has been placed there as the first item that needs to be filled under demographic information. Now the second question is indicate your email. Now indicate my email. Now for instance, my email may be nyachomepeta at yahoo.com. That's my email. Look at now my email also has fitted very well there because I already told the SPSS that this is a string variables. Therefore, I can write on it. Then the second question is indicate, the third question is indicate your gender. So indicate your gender, you check in the questionnaire, the gender is male. So male was recorded as 1. So male is 1. And then number 2, the next question is indicate your highest level of education. Okay, so highest level of education, I may say my highest level of education there, I indicate there 5. What are the codes that did I use? Let me check the highest level of education. You come and indicate there. You come or you compare here. I indicated primary education, secondary education, diploma, undergraduate, masters, and PhD. I may come here and then I say here. I may come here and then I come here and indicate number 6. Come here and then I indicate number 6. When I indicate number 6, I come and indicate like that. Then I come here and then I also the last question, type of religion. My type of religion, I come and there and indicate 1. I come there and indicate 1. Okay, so I've already filled. So these are the way I fill this questionnaire. So I transfer them. So I go to the respondent number 2. Number 2 may be somebody like Ken. So maybe Ken. So you fill their names the way they have written their name in the questionnaire. You transfer them one by one. Now this work may be a little bit laborious, especially when you're working with 600 questionnaires. And that's why you will now require at least to divide those questionnaires to your data class so that they can enter them, and then finally you submerge all the questions together so that you can just have one Spss full with all these questions. So you will find that now the coding component is really not difficult, because now this just requires transferring questions each, and you take one questionnaire, how the respondent has responded in one questionnaire, you enter it all. All the questions, you enter one by one until it is over. So immediately it is over, then you start with the process of what we are doing, that we are doing what we call data screening. So data screening normally takes place after all the data set has been recorded here. Alternatively, instead of just entering this data one by one, you can simply tell your staff to enter the data in Excel, then you bring in the data set from Excel to SPSS, which is usually a very simple process, which we perhaps want to try if you can be able now to just bring, so that you can see how the SPSS is able now to do that kind of work. So it's just very simple. So we just want to do what? We have these icons. I have not explained this icon. We have what you call file. So this is the icon that we can do. There are several operations that you can do here. You can save your SPSS using just file. You come here and then click save as. You can also bring in Excel through this file. You just simply come to Excel, file, then you come and say open. So after open, you come and click data. So once you have clicked data, it will open for you, and then you need to direct SPSS. Where is that your Excel? Where is it? Is it in documents? Is it in desktop? So you need to direct it exactly where it is. For instance, let me test that mine is in the desktop. So I'm already at the desktop. But then in order for me to get Excel, I need to come here in file types, and then I change here to Excel. So you click there and you bring here in Excel, so that now all Excel that are here, I can be able now to do what? I can now be able to bring them forth. So like for instance, my Excel that I want to bring is this consumption analysis. So I just come and click there, and then I wait for what you call a SPSS to bring it. Then I say okay, and the entire data set will be brought into this my data view in what you call in my SPSS. Like now, this is what has come. You come and then say okay. Then the entire data set will be brought down there, and you can be able now to begin the process of doing your data screening automatically after you've already received that. So now this is what I've already received. I need to share it with you. This is what SPSS have brought for me. So you can see that the first numbers, there is what you call gas nature or gas consumption. There is these all are continuous variable. Yes, these are all continuous variable. So let me assess at the data set whether it is too big. Let me see. It's not too big. The data set is 78. There are 78, and all these are values in thousands. Okay, now this is what I already have. So for instance, I already transferred my data set to what you call SPSS. Now I want to begin what you call the process of analysis. And then we have said, before you begin analysis, it is better for you to start with doing what you call data screening. One of the data screening is to check whether you have any of your variable as an outlier. So I want to check in this variable, because these are continuous variables. Do we have an outlier as the first basis of doing what you call preliminary analysis to my data analysis? So I will come here to analyze, and then I come to what we call I come to what we call descriptive statistics, and then I come to explore. So after that explore, I bring all my variables that I want to test the outlier here. So all these variables I want to test the outlier, I will bring them under what you call the dependent list. Then I come here and click what we call, I come here and click plots. And then I click normality plots with the test. and then I also click what you call histogram. So all these two functions are enough to be able to tell me the outlier and also normality. Remember, test for statistical test, when you want to run what you call descriptive statistics, one of the assumptions that you need to do is to test for normality and also test for what you call whether your data set has an outlier. So let me just be able to now click OK, and then I come and say OK, so that I go and take you to what SPSS has generated for me, so that we can be able to interpret whether all those my variables, I don't have an outlier or I have an outlier, and those data sets have a normal distribution or they don't have a normal distribution. If at all there is an outlier, I need to rectify before I can be able to proceed with my analysis. So for instance, somebody may be asking, what is an outlier? An outlier is an extreme value. It might be either too small or too big, and therefore it must either be rectified. And we have two ways by which you can rectify an outlier. One way of doing it is to give it an average value, or simply delete it completely from what you call your data set, so that it does not distort your data set. This is very, very important. These are assumptions for running what you call descriptive statistics, that you must test for absence of an outlier before you can proceed with running your descriptive statistic, or you can also be able to test for normality, so that you know your data set originates from a population with a normal distribution before you can be able to begin running mean and standard deviation. Why we are doing this is because mean, something like mean, a measure of central tendency, is very sensitive to what you call an outlier. An outlier will make us get what you call erroneous reports in our statistics. So let's share with you what you call what SPSS has generated for us. This is the output for the SPSS. So the first, I'm interested in checking for what you call outlier first. An outlier we check by checking at what you call box plot. So I will simply go to the box plot, direct, and then I can be able to look at the histogram. These are the histogram. Histogram simply tells me, give me a hint about the description of my data set. So this is the first variable that we have. So this first variable that we have is called total NC natural gas. So this variable has an outlier. And how do we see an outlier? An outlier is depicted in box plot by the presence of whisker. This extension here is called whisker. And then there's a steric, which means variable number 61 is an outlier under natural gas. So I need to go to that natural gas and change it. So under natural gas, I can even write it in my book that number natural gas, NC total natural gas, variable 61 is an outlier which requires to be rectified. So I check another outlier again. I check another outlier again into the next variable. With the next variable after natural gas, I come down here because I had 4 variables that I need to test simultaneously their presence of outlier. So I come down here and I come to the next variable here, and then the next variable simply does not have an outlier. You can see the residential natural gas does not have an outlier, because you can see very well that you can simply see very well the absence of an outlier in that case, that we don't have an outlier in what you call the natural gas. So this data set, this data set is not divided into, we don't have what you call mean, because if you see this box, this lower region, you can see an element that the lower region, this arrow is not dividing it into equal parts. So there is a lack of symmetry here in this kind of data set, which means if at all it does not meet what we call normality, then we'll be expected to do transformation before we can be able to proceed with running methods of central tendency. This particular data set, because of the kind of the way the box looks, this box is not symmetrically equal. Then I move to the next data set at the same time, because I told you that we need to check this one simultaneously. So I will move now to the next. I will move now to the next variable, so that I also check whether I have an outlier in the next variable. So the next variable after residential gas, I now need to move to the next one here. So the next one, residential gas, I move to the next one here. The next one here is commercial gas. So I have commercial gas. The commercial gas, I also need to check whether we have an outlier here. So I don't have an outlier. There is absence of an outlier in commercial gas. And then I move to the third one now. Finally, I have industrial gas. In our industrial gas also, I don't have an outlier in industrial gas. There is absence of that hysteric indicating where outlier is. So you can be able to look at that. My data set, the 4 variables in my study does not have what you call an outlier. So finally, let me check at the final one here. Electric gas. Electric gas also do not have an outlier. Electric gas do not have an outlier. And therefore, electric gas do not have an outlier in this case. And therefore, I can be able to conclude that my entire data set do not have outlier except the first one, which the outlier is lying in variable number 61. So I need to go back to my data set number 61 and rectify that outlier so that I work with a data set without what you call an outlier. Because remember, we said that outliers, it will distort my data set. They will make me have erroneous report. And it is very vital that the data set that I'm working with is lacking an outlier. So for instance, right now, I need to go direct to NC, natural gas, and I go to what you call where N is 61 and see that outlier. I just move up to where N is 61 and then I rectify that outlier. It is here. So this is what is presented as an outlier. So this is an outlier. For instance, it is an outlier at the upper zone. Simply means it's an outlier which is at the upper zone. So what do we do? In this case, we can give it another value which is not is the medial value. For instance, I may just pick the next immediate data set, like for 47600. Then I just simply say 47600, so that now it is almost the same like this. And then now in that case, I can test it again because the only variable that has an outlier, I can test it again and it will be indicating that it doesn't have an outlier before I can be able now to run what you call methods of central tendency. So let's test it again to ensure that we have now rectified that outlier. So I come back to what you call analyze, descriptive, and then explore command. I come here and then explore command, and then I bring all what I already brought here, I bring them back, and then I only bring what you call the natural gas here because it is what I rectified. And then right now, the option of click, those variables are still there. So I just simply come and say, okay. Then I wait for Spss to populate for me the result. And then I go and check the box plot again now. If at all now, the outlier has been rectified, which simply signifies that my data set does not have an outlier. And I now need to move to check the concept of normality so I can start running for mean and standard deviation. These are what you call prerequisites. They are prerequisites in data analysis, and they are very important that before you can be able to run your data set meets some specific standard before you can be able now to tell us that the mean of the female were this, the standard deviation was this. So before you can give such reports, there must be what you call the basic standard, the minimum standards that your data set must meet. Like all these assumptions must be met before we can be able to employ this. So let's go again and I take you to what Spss has generated for us so that we check now the presence of an outlier in that data set that we rectified. So I just come direct to what you call that outlier. And then when you look at it right now in the screen, is now perfect. So we don't have what you call an outlier. Simply means the data set that I have now has already met what you call the outlier test. So we don't have an outlier completely. So what do I do right now? I need now to go and check the second assumption. And this assumption is assumption on normality. So I can simply take you, for instance, in this case, the normality assumption is being tested. There are several ways of testing it, but I will just simply use what we call the p-value test of normality so that you can be able to see how we are testing normality using what we call the p-value. For instance, now I go to my initial data set here and I check at the data set which meets what we call normality. For instance, if you look at this normal test of normality, so in the under test of normality table, you will find that we have two tests here. There's Kolmogov's Smirnov test and then Sapir-Whorf test. So for where n value, which means the number of trials are less than 2,000, then we normally report the readings on Sapir-Whorf test. Now, when we are testing normality in this table, what I'm looking for is a situation whereby my data set my p-value is non-significant, which means I want a p-value which is greater than 0.05. This based on how I set what you call my hypothesis for testing for normality. Okay, so what is going to happen that the n value here is 78, and therefore the NC natural gas, the p-value is 0.03, which means it's less than 0.05. Okay, the next residential gas is 0.00, which means it is non-significant. The third is non-significant. The fourth is significant. The fifth is significant. So if we now look at our variables, you only find that there are only two variables that meet the test for us to go and run what you call our measures of central tendency. They have already met the criteria for normality. So that is industrial gas is 0.344. And then we also talk about, it's only industrial gas because this 0.07 is like, it is less than 0.00. So all these variables, four of my variables are not qualified to proceed with running what you call my mean and standard deviation, because there's a normality is lacking here. So in this case, what do? I need to do what you call data transformation. I need to do data transformation. I need to transform this data set so that I can be able to do what? I can be able to proceed with running my descriptive as well as inferential statistic that I may be running later. So now, what is the guiding principle when I want to do what you call data transformation? The guiding principle is to check each and every variable in equation. I check at the distribution in the histogram. I need to look at the histogram. Is it skewed to the left or skewed to the right? So I will do what you call general assessment. And for instance, the first variable here, I can say, okay, this one, can somebody tell me, is it skewed to the right or skewed to the left? Because there's what we call an element of skewness here. So you see the concentration is to the left. So, okay, so I look at the second variable, histogram, how histogram is looking like. Now look at this skewed data. It was lacking what you call normality. All these are actually lacking normality except the variable that qualified is the one with a p-value 0.344. So what does it tell me? I need to go back to my data set, which I've already transformed, and then now which I've already met, which I've already qualified for what you call a normality, which I've already qualified for outlier, absence of an outlier. And then I transform those data. So that's what I want to take you to. So I want to go back to the data set because I've already seen where there are problems. So I simply now come back and then I say, I take you back to now, this is my data set. And then now I need now to transform natural gas, residential gas, commercial gas, industrial natural gas is the only one that met what you call normality test. And the last final one also failed to meet what you call the normality condition. So now I need to do what you call data transformation. So which is the transformation that I want to do? Transformation is done on what you call trial and error basis. And that's why we normally say the process of data analysis can take even 1 day, but the process of data screening can take even 1 month. You are still just doing data screening. The so-called, this transformation that we are doing are component of data screening. You need to make your data to be clean. So you have to ensure that you do data cleaning. So the data cleaning process involves testing for these assumptions. And that's why now I want to test for you what you call normality test, and we can simply do what you call transformation, and we can be able to verify whether it is transformed or not. If not, then at least we look for another transformation that perhaps I will take you through tomorrow. But right today, I want to introduce what you call logarithm transformation. So how do I go about it? I want to transform using what you call logarithm. Okay, so I come to what you call transform. I come to transform. So once I come to transform, I'm supposed to come to compute variables. I compute variables. So I need to rename these variables in question. So for instance, the first variable here is called total natural gas. So I can pick this variable the way it is. Okay, I need to rename it. So I can rename it as total. I can rename it as, for instance, I just want to change. So this is total, and C. Remember, naming should not have what you call any abbreviation on it. I can say total and C. and see natural gas, natural gas, okay, log, because I'm checking their logs. So after that, I come here and then I come and say all, come and click here all, and then you come down here, you come down and look for where there is a log value. Look for where there is a log value down here, logarithm to base 10. So this is the log to base 10. You come and click it here. So once you click it here, you want to bring it up. You come and click this arrow. You bring it up like that. Then there's an icon that will be given there. So what do I do in that icon is, I need now to bring the natural gas inside there. I come and click this, and then I bring it inside there. So I've simply transformed, I shall have simply transformed that variable. So I come in there and say, okay.
If we carry out this night, how would we know like?
So it simply tells me that now the way I target variable was not perhaps target variable was not perhaps a target variable had a problem. So let me say perhaps another naming system that it will accept. So for instance, if I say it is
anytime I want iron, I'll just do iron number.
so what?
Cannot hear properly.
Okay, let me come again and click. Now it has accepted. So I go to transform the second variable. I think you are able to see what I've already done. I come again to compute transform variable. I come to transform variable. Then now I will say instead of 1, I will change it just to 0.2. And then I still follow the same process to come to natural logarithm. Down here, I click here, log to base 10, and then I bring it up now. When I bring it up, now bring residential gas. I bring the residential gas, which also never met what you call normality test. Then I bring it inside there. Then I come and say, okay. It has already been transformed. I move now to the second variable, which also failed normality test. And then I transform it again. So when I transform it, I come now, I go to the same process. I come then, I say compute variable. So instead of now, I just change this to be my third variable. So it's going to be 3. So after that, I can simply come here and then remove what I already placed here initially. And then because this is a comma, and then bring now the third variable, place it inside, say okay. And then I've already done that transformation. So I move again to the third case. And then I say compute variable. I hope you are able to see what I'm doing here. All of you are able to see what I'm doing. Transform, I come to compute variable. So I change now, this is the fourth variable, and I just remove what I placed previously inside this place, and then I say now I bring the fourth variable, which is industrial gas, and I bring it inside there. Now this industrial gas, I don't need to transform it because it had already met what you call normality test. It is the one with a p-value greater than 0.05. Then finally, this is the variable, and then I say, okay. Now I've done what? I've done all the transformation. So what I need to do right now is to be able to confirm, if at all, the variables that I've created, have met what you call the normality test. So what do I do now? I need now to run test again for the normality using what's called TCN1, TCN2, TCN3, TCN4, which are the new variables that have already transformed variables that I've created by introducing what you call logarithm. So what I simply come here is simply follow the same procedure of testing for normality, which is analyze, descriptive, then you go to explore. Then after explore, you bring all your variables that you want to test their normality, which is TC1, TC2, TC3, TC4, and then I bring them under dependent list, and then I come to plot and histogram and normality, then I say continue, then I say click OK. Then after that, I wait for SPSS to bring for me what we call the normality test with plot, so that I can check whether right now, do they now meet the conditions for a normal distribution. So I'm just waiting for the SPSS to bring for me what you call the result, the output. Then after the output has been created, I need to share with you what you call the output. So this is the output that has been created. I simply go direct to normality test with plot, and I will be so much interested in checking for what you call the normality test with plots. If at all right now, after transformation, they have now been met with the condition. So if you check at the normality test with plot, the only variable that has met the condition is TNCC01 using the transformation that I've already done. So simply means the variable 2, 3, and 4 have failed to meet what you call normal distribution test using logarithm function. So it simply means I need now to establish I do a further transformation. So I may even introduce what you call square or cube system, because now we have different kinds of normal test for normality that we shall be able to do. So, and then after that, what I'm going to do right now is that, because now this is something that we are going to proceed with tomorrow, because I have to tell you the kind of distribution. When you check the histogram, well, based on the histogram, you need to pick the kind of transformation that's supposed to be done. I just generally introduced what you call logarithm transformation, which I've only succeeded to transform one variable. So the variable that I've transformed, subsequently, I will use it in my analysis of running what you call descriptive statistics, okay? Especially when I'm so much interested in ensuring that I'm working with what you call a normal distribution data set for running things like regression and correlation, okay? Okay, so now for this case, I will be just very much comfortable. I will proceed because my data set is now, there's absence of normality. There's absence of outlier. But then the normality test has not been met in variable 2, 3, and 4. So I want to go back to my original data set. Then I tell you how we need to go about with doing what you call descriptor. For description of this data set, then I simply come to what you call analyze descriptive. Then I come to descriptive here. Then I bring in the data set that I want to describe. Data set that I want to describe here. I bring them here inside here, and then I check perhaps the options, and then I can simply say, okay, okay. Then now I'm taking you back to what you call what I've already populated here. Let me wait for SPSS to generate the result that has come up here. And then we shall be very much particular in reading, in checking at the various readings that are here, so that you can be able now to report the measures of central tendency, because our concern was on descriptive. Remember, when I want to run what you call things like correlation, then all the conditions, the assumption for correlation or regression must be met before I proceed. And one of the assumptions is linearity, homoscedasticity, assumptions. All those I have to pre-test before I can be able now to run those kind of statistics. Okay. So now, when a data set lacks normality, then we normally say that is a data set that is fit for us to run non-parametric statistics. But the fact that these are a continuous variable, we cannot run frequency here. We must go and run measures of central sanity, because I'm dealing with what we call a continuous variable. So this is now, I want to share with you what SPSS has generated for me, so that you can be able now to look at that kind of data that has been generated. So let's go ahead and check at the report that has been generated here, the report that has been generated, the report that has been generated. Let me check at the report that has been generated here, so that you can describe it. And just, yes, this is the result that has already been created. So now you're only supposed to report the n value. You report the minimum, the maximum, and also mean and standard deviation of each and every variable in this study. So that's what you are going to put in under your descriptive statistic on natural gas, residential gas, commercial gas, and industrial gas, and electric gas. So those ones, you are supposed to report them. And remember, we are working with a data set that do not have an outlier. So we assume that our methods, mean and standard deviation, we can rely on it, so that we can describe these given parameters or which we were studying in this particular survey. So after that, I can now stop at that level. I open for any question, and then we can just close our class.
Hello.
Hello, Pizza, can you hear me? Hello, Pizza, can you hear me? Hello, Pizza, can you hear me? Hello, Pizza, can you hear me?